Imagine standing in a dark room with nothing but the stars above you. The sky is vast, endless, and filled with possibilities. You know that each of those stars could have its own planets, its own systems, and maybe even its own forms of life. For centuries, humanity has looked up at the night sky, wondering if we are truly alone in the universe. It's a question that has sparked the imaginations of philosophers, scientists, and dreamers alike. Yet, it wasn't until relatively recently that we began to get closer to an answer. The story of finding life beyond Earth truly begins with the Kepler Space Telescope, launched by NASA in 2009. Kepler was built for one purpose: to find planets outside our solar system, exoplanets, that might be similar to Earth. But how do you find planets when they're so far away, hidden in the vast expanse of space, light years away from us? How do you spot a tiny world orbiting a star that's millions, even billions, of light years away? Kepler used a method known as the transit method to answer this very question. The principle is simple but powerful. Imagine a small planet moving across the face of its star from our perspective on Earth. As the planet passes in front of the star, it causes a small but measurable dimming of the star's light. By detecting and measuring this dimming, astronomers can determine if a planet is passing by and, from that, deduce the planet's size, orbit, and distance from its star. With this technique, Kepler would revolutionize our ability to discover new worlds. When the Kepler mission began, it focused on a small patch of sky in the constellation Cygnus, an area that contained over 150,000 stars. Over the course of its 9-year mission, Kepler detected thousands of exoplanets, some of them similar to Earth in size, orbit, and other key characteristics. But it was the discovery of a planet called Kepler-452b that truly captured the world's attention. This planet, dubbed Earth's cousin, became a symbol of the hunt for extraterrestrial life, a shining beacon of possibility in the search for life beyond our world. Kepler-452b wasn't the first Earth-like planet ever found, but it was the closest thing to a second Earth we had discovered. The discovery of Kepler-452b was groundbreaking for several reasons. Not only was the planet located in the habitable zone of its star, the zone where liquid water could potentially exist on its surface, but it also orbited a star that was remarkably similar to our own Sunday. This, of course, raised the tantalizing question: could life exist there? As we venture deeper into the mystery of Kepler-452b, we must first understand the significance of its discovery. What does it mean for a planet to be Earth-like, and how did Kepler manage to find such a world? To understand this, we need to first look at how Kepler works and what it was designed to do. Kepler was equipped with a wide-field photometer that could measure the light coming from distant stars with incredible precision. By monitoring the brightness of these stars over time, it was able to detect the tiny, periodic dips in brightness caused by planets passing in front of them. This was no easy task, as the dimming of a star due to a planet passing in front of it is incredibly small, less than 1% of the star's total brightness. Yet, Kepler's sensitive instruments were able to detect these tiny variations, allowing astronomers to discover planets that had previously been invisible to our most powerful telescopes. In addition to finding planets, Kepler also provided valuable information about their sizes, orbits, and even atmospheres. It helped scientists determine that there are far more planets in the galaxy than we could have ever imagined. In fact, Kepler's data suggested that there might be more planets than stars in our galaxy. A staggering realization. Among these planets, many were found to be in the habitable zone, the region around a star where conditions are just right for liquid water to exist. Kepler-452b was one of these, making it a particularly interesting candidate in the search for life beyond Earth. But what made Kepler-452b stand out from the other planets in the habitable zone? The answer lies in its star, Kepler-452. This star is a G-type main sequence star, which is the same type of star as our Sun. Kepler-452 is about 6 billion years old, making it slightly older than our Sun, which is around 4.6 billion years old. This means that Kepler-452b orbits a star that is in a mature, stable phase of its life, much like our own Sun. The fact that Kepler-452b orbits a star so similar to our Sun makes it a compelling target in the search for life. It's not just that the planet sits in the habitable zone, it's the combination of the right distance from its star, the right size, and the right conditions that makes Kepler-452b one of the most Earth-like planets we've ever discovered. In fact, Kepler-452b is often referred to as Earth's cousin because of its remarkable similarities to our own planet. It is about 1.6 times the size of Earth, placing it in the category of super-Earths, planets that are larger than Earth but still potentially capable of supporting life. Its orbital period is 385 days, which is just slightly longer than Earth's year. And, just like Earth, it is in a stable orbit around its star, ensuring that any liquid water present on its surface would remain in a stable, life-supporting state. This discovery opened up a new realm of possibilities in the search for extraterrestrial life. Could life exist on a planet so similar to Earth, orbiting a star like our Sun? Could Kepler-452b be the place where we find the answers to one of humanity's most profound questions? As we continue to unravel the mysteries of Kepler-452b, we'll explore the importance of the habitable zone and how it influences a planet's potential to host life. We'll examine the planet's size, distance from its star, and the factors that make it one of the most exciting discoveries in the hunt for extraterrestrial life. But, most importantly, we'll look at what the discovery of Kepler-452b means for the future of space exploration and humanity's quest to find life beyond Earth. As we continue our journey through the cosmos, let's dive deeper into the specifics of Kepler-452b and understand why it has garnered so much attention from scientists and space enthusiasts alike. Kepler-452b is often referred to as Earth's cousin because it shares many key characteristics with our own planet. But what exactly makes Kepler-452b so special? And why do we consider it one of the most exciting discoveries in the search for life beyond Earth? First, let's take a step back and review the basics of this planet. Where it is, what it's like, and why it's often compared to Earth. The location of Kepler-452b. Kepler-452b is located 1,400 light-years away from Earth in the Cygnus constellation, which is positioned in the northern part of the sky. To put this distance into perspective, 1 light-year is the distance that light travels in 1 year, about 5.88 trillion miles, 9.46 trillion kilometers. This means that Kepler-452b is incredibly distant, but it's still one of the closest Earth-like planets we've discovered. Given the vastness of space, finding a planet this similar to Earth, even at such a distance, is remarkable. Despite the large distance between us and Kepler-452b, the discovery is significant for 2 main reasons: its star and its location in the habitable zone. Both of these factors play a crucial role in its potential to support life, and both are key reasons why Kepler-452b is such an exciting discovery. Kepler-452, the star behind Kepler-452b. The star that Kepler-452b orbits is called Kepler-452, and it is one of the most important aspects of this planet's potential to support life. Kepler-452 is a G-type main sequence star, which places it in the same category as our Sun. These stars are the most common in our galaxy and have relatively stable lifetimes, making them ideal candidates for hosting habitable planets. The Sun, for instance, has been shining for about 4.6 billion years, and it is expected to continue burning for another 5 billion years before it reaches the end of its life. Kepler-452 is slightly older than our Sun, at around 6 billion years old, and is about 10% brighter than the Sun. This makes Kepler-452b's orbit similar to that of Earth, and the star's stability makes it an excellent candidate for life-supporting conditions. This is significant because stars that are too young, too hot, or too unstable can produce high levels of radiation or fluctuate in brightness, which could harm or even prevent the development of life on surrounding planets. Kepler-452's relatively stable nature creates an environment that might be ideal for life, just as our Sun has done for Earth. In essence, Kepler-452 is an older and slightly brighter version of our Sun, and this similarity is one of the main reasons why Kepler-452b has earned the title of Earth's cousin. Size and composition: Kepler-452b as a super-Earth. Kepler-452b is approximately 1.6 times the size of Earth, placing it in the category of a super-Earth, a type of exoplanet that is larger than Earth but still potentially capable of supporting life. Despite its larger size, Kepler-452b's composition is believed to be similar to Earth's, with a rocky surface that might host oceans, mountains, and other geological features. The planet's mass and size make it capable of retaining a thick atmosphere, an important factor in supporting life. Larger planets tend to have stronger gravity, which helps them hold onto a thicker, more stable atmosphere, protecting the planet's surface and helping regulate temperatures. This would be crucial for Kepler-452b's potential to support liquid water on its surface, as a stable atmosphere is needed to maintain the right conditions for water to exist in liquid form. Given that Kepler-452b is a super-Earth, its gravity is likely stronger than Earth's. This could mean that any life forms that evolved on Kepler-452b would need to adapt to this higher gravitational pull, which would affect everything from the size of organisms to how they move and interact with their environment. While this doesn't rule out the possibility of life, it does suggest that any potential life on Kepler-452b could have evolved differently from life on Earth. Orbital characteristics: a year on Kepler-452b. Kepler-452b has an orbital period of 385 days, which means that its year is just slightly longer than an Earth year, 365 days. This is another factor that contributes to the Earth-like nature of Kepler-452b. The fact that its orbital period is so similar to Earth suggests that the planet is in a stable, circular orbit around its star, which is important for maintaining relatively consistent temperatures over time. In addition to its year length, Kepler-452b's orbit places it within the habitable zone of its star. The habitable zone, or the Goldilocks zone, is the region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Too close to the star and the planet would be too hot, too far away and it would be too cold. Kepler-452b's position in this zone places it in the perfect position to possibly host liquid water on its surface, one of the key ingredients for life. Interestingly, Kepler-452b orbits its star at a distance of 1.04 astronomical units, AU, nearly identical to Earth's distance from the Sun, which is $1 Australian. This similarity in orbital distance suggests that Kepler-452b receives roughly the same amount of stellar radiation as Earth does from our Sun, which is another reason why it is considered to be so Earth-like. What about the planet's atmosphere? While we know a great deal about Kepler-452b's size, orbit, and potential to support liquid water, much about its atmosphere remains a mystery. One of the primary factors in determining whether a planet is truly habitable is the composition of its atmosphere. Earth's atmosphere, for example, is made up of a mix of nitrogen, oxygen, and trace gases, which create a stable environment for life. But what about Kepler-452b? At the moment, scientists don't know for certain whether Kepler-452b has an atmosphere, let alone what it might be composed of. It's possible that the planet's atmosphere could be thick and rich in gases like carbon dioxide, nitrogen, and water vapor, all of which are critical for supporting life. Alternatively, Kepler-452b could have a thinner atmosphere, or even no atmosphere at all, which would make the planet less hospitable to life. One of the challenges in studying the atmosphere of distant planets like Kepler-452b is the distance involved. With the planet located 1,400 light-years away, it's difficult to send spacecraft there to take direct measurements. However, scientists are working on ways to study the atmospheres of exoplanets using spectroscopy, a technique that involves analyzing the light passing through a planet's atmosphere as it moves in front of its star. This method can reveal clues about the chemical composition of a planet's atmosphere, including the presence of key biosignatures, gases that could indicate the presence of life. In our search for life beyond Earth, one of the most important factors that determines whether a planet could support life is its location in relation to its star. This location, often called the Goldilocks zone or the habitable zone, is the region around a star where the temperature is just right, not too hot and not too cold, for liquid water to exist on the surface of a planet. Water, as we know, is a crucial element for life as we understand it. On Earth, water makes up a significant part of all living organisms, serves as the medium for most biochemical reactions, and regulates our climate. For this reason, finding planets that sit in their star's habitable zone is one of the main criteria in the search for extraterrestrial life. If a planet is in the Goldilocks zone, the chances are higher that it could have conditions similar to Earth, where liquid water is stable and could support the development of life. But what exactly makes this zone so important, and how does Kepler-452b fit into this concept? What is the Goldilocks zone? The Goldilocks zone is a term that has captured the imagination of many because it is based on the classic Goldilocks story, where the porridge is just right. In this analogy, the planet's distance from its star is just right for the presence of liquid water. The region around a star where conditions are neither too hot nor too cold for water to exist is what we call the habitable zone. The Goldilocks zone is not a fixed distance. It depends on several factors, including the star's luminosity, how much light and heat the star emits, and the planet's atmospheric conditions. For instance, a smaller, cooler star will have a habitable zone that is much closer to the star, whereas a larger, hotter star will have a habitable zone that is farther out. This zone is not just about water. It is about finding the perfect balance between a planet's ability to maintain liquid water on its surface and the conditions necessary for life. Too close to the star, and the planet may experience a runaway greenhouse effect, like Venus, where temperatures soar and water evaporates. Too far from the star, and the planet becomes frozen, like Mars or Pluto, with water locked in ice. The Goldilocks zone offers an ideal balance of temperature, radiation, and conditions that might allow life as we know it to thrive. Kepler-452b's position in the Goldilocks zone. Kepler-452b is often hailed as one of the most Earth-like planets discovered to date, and one of the main reasons for this is its position within the habitable zone of its star, Kepler-452. The planet orbits its star at a distance of about 1.04 astronomical units, AU, almost exactly the same distance as Earth's orbit around our Sun, $1 Australian. This places Kepler-452b right in the Goldilocks zone of its star, meaning it receives roughly the same amount of solar radiation as Earth does from the Sun. This is an exciting fact because, based on our current understanding of how life works, being in the habitable zone increases the likelihood of liquid water being present on the planet's surface. While this doesn't guarantee the presence of water, other factors, such as the planet's atmosphere, surface conditions, and internal heat, also play a role. It is one of the key ingredients that makes Kepler-452b so intriguing. The fact that Kepler-452b is in the habitable zone of its star means that it has the potential to be warm enough to allow liquid water to exist, but not so hot that it would boil away. Additionally, being at a similar distance from its star as Earth gives Kepler-452b a similar climate, or at least the possibility of a climate conducive to supporting life. What makes Kepler-452b's habitable zone so special? Kepler-452b's location in the habitable zone is not only important because of the potential for liquid water, but also because of the age of its star. Kepler-452b orbits a star that is about 6 billion years old, slightly older than our Sun, which is about 4.6 billion years old. This means that Kepler-452 star has been around for longer, allowing more time for life to potentially develop on Kepler-452b, if it hasn't already. Our own Sun is still in the prime of its life, but in about 5 billion years, it will expand into a red giant, scorching Earth's surface and making it impossible for life to continue. By contrast, Kepler-452 star is in a stable phase of its life cycle, making the planet's environment potentially much more stable over a longer period of time. If life were to form on Kepler-452b, it could have had billions of years to develop, giving it more time than Earth has had for evolution. Another special characteristic of Kepler-452b's position is its orbital stability. Kepler-452b has an orbital period of 385 days, which is almost identical to Earth's year, 365 days. This means that Kepler-452b experiences seasons that are similar in length to ours. This stable orbit, combined with the planet's position in the Goldilocks zone, could provide a climate system conducive to the development of liquid water and, ultimately, life. Why the habitable zone matters for life. The presence of liquid water is one of the most crucial elements for life as we understand it. Water serves as a medium for countless biochemical reactions in organisms and is essential for processes like photosynthesis, which allows plants to produce food. On Earth, all known life forms rely on water to sustain life. It is, without a doubt, the most important solvent and the key to life's existence on our planet. For a planet to support life, its distance from its star must allow for water to remain in a liquid state, not frozen solid or evaporated into the atmosphere. If a planet like Kepler-452b can sustain liquid water, it increases the chances that life could arise there. This is why astronomers are so keen on studying planets in the habitable zone. In addition to liquid water, the Goldilocks zone provides a stable environment in which planets can experience gradual climate changes and seasons. This creates an ecosystem that could support a variety of life forms. If Kepler-452b has a thick atmosphere, it could also protect the planet from harmful radiation, regulate temperatures, and preserve liquid water on its surface. It's not just about the presence of water, though. The Goldilocks zone also allows for the planet to have the right conditions for a carbon-based biosphere, the type of biosphere that supports life on Earth. With the right distance from the star and the possibility of liquid water, the chances of having a sustainable, life-supporting environment increase. What we don't know. Could Kepler-452b have liquid water? Despite the excitement surrounding Kepler-452b's position in the habitable zone, we still don't know for certain whether the planet has liquid water on its surface. There are many factors at play when it comes to determining the presence of water, and the distance from the star is just one piece of the puzzle. One important factor is the planet's atmosphere. A thick atmosphere can help trap heat and maintain surface temperatures suitable for liquid water. If Kepler-452b has an atmosphere, it could create a stable climate that allows liquid water to exist, just as Earth's atmosphere regulates the temperatures we experience. However, we don't know much about Kepler-452b's atmosphere yet. While it is possible that the planet has an atmosphere similar to Earth's, there is also the possibility that the planet could be lacking a thick atmosphere, or that it might have an atmosphere that is toxic or unsuitable for life. Further studies using advanced telescopes, like the James Webb Space Telescope, JWST, are needed to analyze the planet's atmosphere in more detail. We also don't know what the surface of Kepler-452b looks like. Could have oceans, deserts, or even volcanic landscapes. The surface conditions of the planet will play a huge role in determining whether liquid water is present and whether it can support life. When we think of Earth, the atmosphere is one of the most fundamental elements that make life possible. It protects us from harmful radiation, regulates our climate, and, of course, provides the air we breathe. But what if the atmosphere of another planet isn't quite like Earth's? What if it's thinner, thicker, or composed of entirely different gases? The atmosphere is a planet's first line of defense against the harshness of space, and it plays a pivotal role in determining whether a planet can support life. In the case of Kepler-452b, the question is whether this distant world has an atmosphere that can support life in the same way that Earth's atmosphere sustains us. The answer to this question will have profound implications for the planet's habitability. Let's explore why the atmosphere is so crucial for life and what we know, and don't know, about Kepler-452b's atmospheric conditions. Why the atmosphere matters. The atmosphere is far more than just a layer of air around a planet. It is a complex system that affects the planet's temperature, regulates the availability of liquid water, and shields the surface from harmful radiation. Life, at least as we know it, relies on a stable atmosphere to create the right conditions for biochemical reactions to take place. On Earth, our atmosphere is composed of 78% nitrogen, 21% oxygen, and trace amounts of other gases like argon, carbon dioxide, and neon. This balance of gases is key to supporting life as we know it. Oxygen is essential for respiration, while carbon dioxide plays a role in maintaining the greenhouse effect, trapping heat and preventing the planet from becoming too cold. Nitrogen serves as an inert gas, acting as a buffer for more reactive gases and helping to regulate the atmospheric pressure. The greenhouse effect is another key aspect of why the atmosphere is so important. It occurs when gases like carbon dioxide, methane, and water vapor trap heat in a planet's atmosphere, preventing it from escaping back into space. This natural process keeps Earth warm enough to support life. Without the greenhouse effect, Earth's average temperature would be too cold for liquid water to exist, making life as we know it impossible. For any planet, the presence of the right balance of gases in the atmosphere is a crucial condition for life. This is why studying a planet's atmosphere is one of the first steps in determining whether it might host life. What we know about Kepler-452b's atmosphere. While Kepler-452b has captivated scientists with its Earth-like size, orbital distance, and potential for liquid water, there is one major mystery that still surrounds this exoplanet: its atmosphere. We know that Kepler-452b orbits a G-type main sequence star, just like our Sun. And because it lies within the habitable zone, the region around the star where liquid water could exist, it's likely that Kepler-452b might have an atmosphere. However, what that atmosphere is composed of, and whether it is thick enough to support life, remains unknown. Unfortunately, there are several challenges in determining the composition of Kepler-452b's atmosphere from such a vast distance. Kepler-452b is located 1,400 light-years away from Earth, which makes it incredibly difficult to study in detail. We can't send probes to this planet to take direct measurements, so scientists have to rely on indirect methods to learn more about the planet's atmospheric conditions. One of the most promising techniques for studying distant planets' atmospheres is spectroscopy. This method involves analyzing the light that passes through a planet's atmosphere as it transits across its star. By studying the light spectrum, scientists can identify the gases present in the planet's atmosphere, including key biosignatures like oxygen, carbon dioxide, methane, and water vapor. These gases, when found together, could indicate biological processes, an exciting prospect in the search for extraterrestrial life. While Kepler's data has provided some preliminary insights into Kepler-452b's characteristics, more detailed observations using advanced instruments are necessary to understand the planet's atmosphere. Instruments like the James Webb Space Telescope, JWST, which is set to launch soon, will be able to perform detailed spectroscopic analyses of exoplanet atmospheres, including Kepler-452b, with greater precision. JWST will give us a deeper understanding of the composition of Kepler-452b's atmosphere and, more importantly, whether it contains any of the gases necessary for supporting life. The potential gases in Kepler-452b's atmosphere. What kind of atmosphere could Kepler-452b have? If it's anything like Earth's, it would be composed of nitrogen, oxygen, and trace amounts of carbon dioxide. However, we must consider the possibility that Kepler-452b's atmosphere could be significantly different, with gases that are either toxic or more conducive to alien forms of life. Let's explore some of the key gases that could be present in Kepler-452b's atmosphere. Oxygen. One of the most significant indicators of life on Earth, Oxygen is produced by plants and microorganisms through the process of photosynthesis. Its presence in an exoplanet's atmosphere could suggest biological activity. However, oxygen is a reactive gas, and if it's found in large quantities, it could indicate that some form of life has evolved to produce it. Carbon dioxide, CO2 on Earth. Carbon dioxide plays a key role in the greenhouse effect, helping to regulate the planet's temperature. In the right quantities, CO2 could provide a stable climate on Kepler-452b, keeping temperatures warm enough for liquid water to exist. However, too much CO2 could result in a runaway greenhouse effect, making the planet too hot to support life. Methane, CH4 methane, is another key biosignature gas. On Earth, methane is primarily produced by biological processes, particularly by bacteria that live in oxygen-poor environments. If methane is found in Kepler-452b's atmosphere, it could suggest the presence of microbial life, or it could indicate volcanic activity or other non-biological processes. Water vapor, H2O water vapor, is essential for life as we know it. If Kepler-452b has water vapor in its atmosphere, it would be a strong indication that liquid water exists on the planet's surface. However, water vapor is also an important greenhouse gas, contributing to the warming of the planet. The presence of water vapor would be a strong clue that Kepler-452b has an environment that is hospitable to life. Nitrogen, N2 nitrogen, is the most abundant gas in Earth's atmosphere, and it serves as an inert buffer to protect more reactive gases. If Kepler-452b has an atmosphere that is primarily composed of nitrogen, it would be a sign that the planet has a stable, Earth-like environment. Nitrogen is also essential for the formation of proteins and DNA, two key components of life. Other trace gases. There are many other gases that could potentially be present in Kepler-452b's atmosphere, such as argon, neon, and ozone. The presence of certain trace gases could provide important clues about the planet's atmospheric dynamics and potential for supporting life. What are the challenges of Kepler-452b's atmosphere? While Kepler-452b's position in the Goldilocks zone and its potential for liquid water are exciting, the planet's atmosphere also presents several challenges. For one, even if the planet has an atmosphere, it could be too thin or composed of gases that make it difficult for life to thrive. If Kepler-452b's atmosphere lacks the right gases for life or is too thin to trap heat, the planet might be too cold or too unstable to support liquid water. Another challenge is the planet's gravity. Kepler-452b is about 1.6 times the size of Earth, which suggests that it might have stronger gravity. While stronger gravity can help a planet retain a thick atmosphere, it could also create conditions that are challenging for life as we know it. Life forms on Kepler-452b would have to adapt to this stronger gravitational pull, which could affect their biology in ways we can't yet predict. Lastly, we must consider the possibility of atmospheric escape. If Kepler-452b is too close to its star, it could experience solar winds or stellar radiation that strip away its atmosphere over time. This could make it harder for the planet to retain the gases necessary for life. The importance of future research. The mystery of Kepler-452b's atmosphere is not one that can be solved immediately. With current technology, it's impossible to study the planet in enough detail to determine its atmospheric composition conclusively. However, upcoming missions, such as the James Webb Space Telescope, JWST, will be able to study the atmospheres of distant planets with greater precision. JWST's advanced instruments will allow scientists to analyze the light passing through Kepler-452b's atmosphere and detect the presence of key biosignatures, helping us determine if the planet could support life. Ultimately, the atmosphere is the key to unlocking Kepler-452b's potential for habitability. If it contains the right mix of gases, it could be a place where life thrives, or at the very least, where life could have evolved. For now, we can only speculate, but with future research and advanced technology, the secrets of Kepler-452b's atmosphere may soon be revealed. As we venture deeper into the mysteries of Kepler-452b, the question that continues to resonate in the minds of astronomers and astrobiologists is, could this distant planet, orbiting a star 1,400 light-years away, harbor life? While much of what we know about Kepler-452b is based on indirect evidence and educated assumptions, there are certain clues that suggest this planet might have the potential to support life in some form. We've already discussed how Kepler-452b is similar to Earth in key ways: its size, its distance from its star, and its position within the habitable zone. But what are the critical factors that determine whether a planet can actually host life? Liquid water, a stable atmosphere, a suitable climate. These are just a few of the pieces of the puzzle that we must examine when considering the planet's potential to support life. Let's break it down and look at the most important factors that contribute to Kepler-452b's ability to host life. The presence of liquid water, the foundation of life. Water is, by far, one of the most essential ingredients for life as we know it. On Earth, water makes up about 60% of the human body, covers about 70% of the planet's surface, and is a crucial solvent in countless biochemical processes. From photosynthesis in plants to cellular respiration in animals, water plays an indispensable role in life on Earth. But could Kepler-452b have the right conditions for liquid water to exist? Kepler-452b's location in the habitable zone of its star is one of the most promising factors that increase its potential for liquid water. The habitable zone is the region around a star where the temperatures are not too hot and not too cold for liquid water to remain stable on the surface. Too close to the star, and a planet's water would evaporate into steam. Too far, and it would freeze into ice. Kepler-452b, orbiting a star almost identical to our Sun, sits at a distance from its star that allows for the possibility of liquid water, a critical factor for the development of life. However, having the right temperature is just one aspect of the equation. Kepler-452b's atmosphere would also play a significant role in determining whether liquid water could exist on its surface. As we've discussed earlier, a thick atmosphere rich in greenhouse gases, such as carbon dioxide or water vapor, could help to maintain a stable, life-supporting climate by trapping heat through the greenhouse effect. This effect helps regulate the planet's temperature and prevent it from becoming either too hot or too cold for liquid water to exist. While we can't yet say with certainty whether Kepler-452b has liquid water on its surface, the conditions we know about, the planet's distance from its star, its size, and its position in the habitable zone, suggest that it is possible. The role of the atmosphere in protecting life. We've established that liquid water is essential for life, but there's another crucial factor to consider: the atmosphere. A planet's atmosphere is its protective shield, regulating its temperature, blocking harmful radiation, and helping to maintain stable conditions for life. Without a stable atmosphere, a planet like Kepler-452b could experience extreme temperature fluctuations, making it difficult for life to survive. For Kepler-452b, the possibility of a thick, Earth-like atmosphere is key to determining whether it could support life. If the planet has an atmosphere composed of gases like nitrogen, oxygen, carbon dioxide, and water vapor, it could trap heat and regulate the planet's climate. This would create the perfect conditions for liquid water to exist on the surface, ideal for the development of life. Furthermore, a strong atmosphere would also protect the planet's surface from harmful radiation, particularly ultraviolet radiation from the star. On Earth, our atmosphere absorbs most of the sun's harmful radiation, protecting life from damage. If Kepler-452b has a similar atmosphere, it could shield any potential life forms on the planet's surface, allowing them to thrive without constant exposure to dangerous radiation. However, the composition of Kepler-452b's atmosphere remains one of the great unknowns. While we know that the planet lies in the habitable zone and has the potential for an atmosphere, we have yet to determine whether it has the right balance of gases to support life. Future studies, especially using the James Webb Space Telescope, JWST, will be crucial for understanding the makeup of the atmosphere and its ability to sustain life. Climate stability, the key to long-term habitability. The long-term habitability of a planet is not just about having water and an atmosphere, it's also about having a stable, predictable climate. On Earth, our climate has remained relatively stable for billions of years, allowing life to evolve and thrive. A stable climate ensures that liquid water doesn't evaporate or freeze, and it allows for the gradual changes that drive evolution and the development of complex life. Kepler-452b's climate would depend largely on its orbital stability and the properties of its atmosphere. As we've discussed, the planet has an orbital period of 385 days, which is almost identical to Earth's year of 365 days. This orbital stability suggests that Kepler-452b could experience seasons similar to those on Earth, with temperature fluctuations that are not too extreme, allowing liquid water to exist in stable conditions. In addition, the presence of a thick atmosphere, especially one rich in greenhouse gases, could further stabilize the climate. By trapping heat and ensuring a steady temperature, the atmosphere would prevent extreme shifts between day and night or summer and winter. This would create a more Earth-like climate, conducive to the existence of life. However, it's important to remember that even small fluctuations in a planet's climate could have major consequences for the development of life. For example, if Kepler-452b's atmosphere is too thin, or if its climate is subject to drastic changes, it could result in extreme temperature swings, making it more difficult for life to survive. While we cannot yet measure these factors directly, we can use the knowledge we have of other planets and stars to hypothesize what the climate on Kepler-452b might be like. The possibility of a diverse biosphere. If Kepler-452b does indeed have liquid water and a stable atmosphere, it could be a perfect environment for life to take root and evolve. Just as Earth's oceans, rivers, and lakes provided the perfect conditions for life to evolve and diversify, Kepler-452b's oceans, if they exist, could provide similar opportunities for evolution. The key to understanding Kepler-452b's potential for hosting life is its ability to support a diverse biosphere, a system in which organisms can evolve, adapt, and interact with their environment. On Earth, life evolved in the oceans before expanding to land, air, and other ecosystems. If Kepler-452b has oceans or bodies of liquid water, it could follow a similar pattern, with the first forms of life emerging in the water and eventually evolving into more complex organisms. The size of Kepler-452b, about 1.6 times the size of Earth, suggests that the planet may have a more diverse geography, with mountains, valleys, and oceans that could create different habitats for organisms to occupy. The gravitational pull on Kepler-452b would be stronger than Earth's, which could affect the kinds of organisms that develop. Life on Kepler-452b might evolve to be stronger, more resilient, or adapted to the higher gravity. One of the most exciting possibilities is the potential for intelligent life. If Kepler-452b has the right conditions for life to evolve and adapt over billions of years, there is a possibility that life on this planet could follow a path similar to ours. Perhaps one day Kepler-452b could be home to creatures who think, create, and explore their own world in ways we can only imagine. The search for biosignatures, the holy grail of discovery. While all of this is fascinating, we must also consider the most important question of all. How do we know if Kepler-452b actually hosts life? The answer lies in the search for biosignatures, indicators of life that can be detected in the atmosphere or on the surface of a planet. For example, the presence of gases like oxygen, methane, and carbon dioxide, especially in the right ratios, could suggest the existence of biological processes. Life on Earth constantly produces these gases through respiration, photosynthesis, and other processes. If Kepler-452b's atmosphere contains similar gases, it would provide strong evidence that life is or has been present on the planet. In addition to atmospheric biosignatures, scientists are also looking for surface biosignatures, signs that life has interacted with the planet's surface. This could include changes in the chemical composition of the soil or the presence of specific minerals that are only formed in the presence of life. The discovery of biosignatures on Kepler-452b would be a game-changer in the search for life beyond Earth. It would be the first concrete evidence that life exists on another planet, and it would open the door to further exploration and study of this fascinating world. One of the most fascinating aspects of Kepler-452b is the star around which it orbits, Kepler-452. This star is not only similar to our Sun in terms of its type and size, but it is also older, giving the planet it hosts a unique edge in the search for extraterrestrial life. The age of Kepler-452 star is a crucial detail because it impacts the potential for the development of life on Kepler-452b. Let's delve deeper into why the age of a star matters and what it means for the life-supporting possibilities of Kepler-452b. Kepler-452 star, a Sun-like neighbor. Kepler-452 is classified as a G-type main sequence star, just like our Sun. This means it is in the same stage of its stellar life cycle, burning hydrogen in its core to produce energy. G-type stars, like the Sun, are the most common types of stars in our galaxy. They are typically stable, shining for billions of years, which makes them good candidates for hosting planets with stable climates. Ideal conditions for life to develop. However, what sets Kepler-452 apart is its age. Kepler-452 is about 6 billion years old, whereas our Sun is only about 4.6 billion years old. This means that Kepler-452 is older and, in astronomical terms, is considered to be in the later stages of its main sequence phase, the phase of its life when it burns hydrogen in its core. This is important because stars go through various stages during their lifetimes, and their luminosity, brightness, changes over time. As Kepler-452 ages, it has been gradually increasing in luminosity. In fact, it is currently about 10% brighter than our Sun, which means it provides slightly more energy to its planets. This gradual increase in brightness is typical of stars like Kepler-452 as they grow older. Over the next billion years, Kepler-452 will continue to brighten, eventually leaving the main sequence phase and transitioning into a red giant star. However, for the next several billion years, the star will remain in a relatively stable phase, providing a consistent energy source for any planets orbiting it. The benefits of Kepler-452b orbiting an older star. So, why is Kepler-452's age important in the search for life on Kepler-452b? The primary reason is that an older star provides a more stable environment for its planets. The fact that Kepler-452 has been shining for around 6 billion years means that the planet in its habitable zone, Kepler-452b, has had more time to develop and evolve. Compare this to younger stars, which can be more volatile. Young stars often experience high levels of stellar activity, including powerful flares and intense radiation, which can disrupt the conditions necessary for life to develop on nearby planets. In contrast, Kepler-452, being a mature star, is more stable. This would have allowed any potential life on Kepler-452b more time to evolve and adapt, making the planet a much more promising candidate in the search for extraterrestrial life. In fact, Kepler-452b is an especially intriguing planet because it has likely had a stable climate for billions of years, just as Earth has had a relatively stable climate throughout its history. Stability is key in allowing life to evolve, and the fact that Kepler-452b orbits a star that has been providing consistent energy for over 6 billion years means that the planet could have experienced the necessary conditions for life to emerge and thrive. Kepler-452b, a planet with potential for long-term habitability. The age of Kepler-452 star also suggests that Kepler-452b could have long-term habitability. Just like Earth, which has had billions of years to sustain life, Kepler-452b could have experienced a similar timeline. If life were to exist on Kepler-452b, it would have had plenty of time to evolve, adapt, and diversify. Life on Earth has evolved over billions of years, from simple microorganisms to complex plants and animals. Similarly, If Kepler-452b has been receiving consistent energy from its star for billions of years, the potential for life to evolve on this planet is immense. Furthermore, the longevity of Kepler-452 star means that the planet has likely had time to go through different climatic cycles. Similar to Earth's history of glaciations and warmer periods, these cycles could have created opportunities for life to evolve in response to changing conditions. A planet's climate doesn't have to be constant for life to thrive. In fact, change is often what drives evolution. The gradual warming of Kepler-452 star over the next billion years could also create new opportunities for life on Kepler-452b, should life already exist or evolve in the future. The Goldilocks zone and the star's stability. Kepler-452b's position within the habitable zone is a crucial factor in its potential to support life. As we discussed earlier, the habitable zone is the region around a star where conditions are just right for liquid water to exist. Not too hot, not too cold. Because Kepler-452 is older and brighter than our Sun, it has had a much more gradual and stable increase in brightness. This gradual change has kept Kepler-452b in the habitable zone for a much longer period, allowing it to experience a stable temperature range for billions of years. By contrast, younger stars can fluctuate more rapidly in terms of brightness and radiation. These fluctuations could make it harder for planets to maintain a stable climate, potentially rendering them unsuitable for life. Kepler-452, having provided consistent energy for billions of years, offers a much more stable environment for any potential life on Kepler-452b. This stability is key for long-term habitability. Planets that are too close to their stars can experience catastrophic heating effects, while planets that are too far might become frozen. Kepler-452b, orbiting a stable, older star in the habitable zone, might have had the right conditions to develop and maintain a thriving biosphere, much like Earth did over its early history. Kepler-452b's age and the search for life. The age of Kepler-452b's star is also important because it offers a unique window into the history of life in the universe. If Kepler-452b has had billions of years to evolve and develop under the stable energy provided by Kepler-452, this planet might offer us clues about how life could emerge and evolve on other planets. It could act as a laboratory for understanding the potential diversity of life that might exist on planets orbiting other stars. On Earth, life has evolved over a long period, slowly but steadily adapting to changing conditions. Kepler-452b, with its older star and stable conditions, could provide a similar environment for life to evolve, if it hasn't already. This makes Kepler-452b an incredibly important object of study for astrobiologists. As we search for life beyond Earth, understanding how life might evolve on planets with mature stars like Kepler-452 is essential. In addition, if life does exist or ever existed on Kepler-452b, it could help us understand the timing of life's emergence. Just as Earth experienced its own unique process of evolution, Kepler-452b's life cycle could offer insights into how life begins, evolves, and potentially survives in different environments. The end of Kepler-452's life. What's next for Kepler-452b? While Kepler-452 star is currently in a stable phase, it will eventually run out of hydrogen fuel in its core. When that happens, the star will begin to transition into a red giant, expanding outward and engulfing nearby planets. In the distant future, this transformation will cause Kepler-452b to experience dramatic changes in temperature, and the conditions necessary for life would no longer exist. But for now, Kepler-452 is in the prime of its life, and this provides a stable environment for Kepler-452b to potentially harbor life. For now, though, Kepler-452 star is stable and continues to shine steadily, offering Kepler-452b the possibility of a long period of habitability. The planet is in the perfect position for life to evolve, if it hasn't already. As humanity continues to explore the vast frontiers of space, the question of whether we could one day inhabit planets beyond Earth becomes more pressing. While the discovery of exoplanets like Kepler-452b, which is Earth-like in many ways, fuels our hopes of finding a new home, It also raises the exciting possibility of terraforming, the process of altering a planet's environment to make it more suitable for human habitation. Kepler-452b is often referred to as Earth's cousin because of its remarkable similarities to our own planet. It is roughly 1.6 times the size of Earth, or a super-Earth, and orbits its star in the habitable zone, where conditions might allow liquid water to exist on its surface. But could we actually transform Kepler-452b into a world where humans could live? Let's explore the potential of terraforming this distant exoplanet and the challenges we might face. What is terraforming? Terraforming is the theoretical process of deliberately modifying the atmosphere, temperature, surface, and ecology of a planet to make it habitable for humans. The idea of terraforming has been a popular topic in science fiction, but advances in space science and technology are making it seem like a more plausible endeavor. The concept involves making a planet's environment more like Earth's, with breathable air, liquid water, stable temperatures, and a sustainable ecosystem. In practice, terraforming could involve altering a planet's atmosphere to create the right balance of gases, changing the surface temperature through artificial means, and possibly introducing plant life to create an oxygen-rich atmosphere. While it's a monumental challenge requiring incredible technological innovation, it's not entirely beyond the realm of possibility, especially if a planet is as Earth-like as Kepler-452b appears to be. Kepler-452b's suitability for terraforming. Kepler-452b has many of the characteristics that make it a prime candidate for terraforming. First, its size, about 1.6 times the size of Earth, puts it in the category of super-Earths, which are planets larger than Earth but still potentially habitable. Its gravity would be stronger than Earth's, which could help it retain a thicker atmosphere, an essential element for terraforming. Kepler-452b orbits its star, Kepler-452, at a distance of 1.04 astronomical units, AU, almost exactly the same as Earth's distance from the Sun. This places the planet in the habitable zone, where temperatures could allow liquid water to exist on its surface. Liquid water is one of the most critical factors for life, and its presence would make Kepler-452b a far better candidate for terraforming than a planet that is either too hot or too cold. Additionally, the star Kepler-452 is similar to our Sun, providing a steady, reliable source of energy. Its age, 6 billion years old, indicates that it is stable and likely to remain so for billions of years to come, ensuring that any terraforming efforts would have a stable source of energy to support life for the long term. In theory, Kepler-452b is already in the right location to support life, but there are several significant challenges that would need to be overcome to make it habitable for humans. Let's explore how these challenges could be addressed and what steps might be required to terraform the planet. The challenges of terraforming Kepler-452b. While Kepler-452b has many similarities to Earth, it is still an alien world located 1,400 light-years away from our own. Transforming such a planet into a suitable home for humans presents an enormous challenge. Here are the key factors that would need to be addressed. Atmosphere. Creating the right gaseous composition. One of the primary challenges of terraforming Kepler-452b would be altering its atmosphere to make it breathable for humans. The atmosphere would need to be composed of oxygen, nitrogen, and other gases in the right proportions to support life. Earth's atmosphere is made up of 21% oxygen and 78% nitrogen, with trace amounts of other gases like argon and carbon dioxide. A similar mix would be necessary on Kepler-452b for humans to survive. If Kepler-452b's atmosphere is too thin or lacks the right gases, we would need to add oxygen, nitrogen, and other necessary elements. One possibility is to import gases from elsewhere, perhaps by breaking down water ice from the planet's surface into hydrogen and oxygen and releasing the hydrogen into space while retaining the oxygen. Alternatively, we might need to introduce plants or algae to produce oxygen through photosynthesis, gradually enriching the atmosphere. Another important consideration is the greenhouse effect. If Kepler-452b's atmosphere doesn't have the right balance of gases to maintain stable temperatures, We could attempt to introduce greenhouse gases, such as carbon dioxide and methane, to warm the planet. These gases would trap heat and prevent the planet from becoming too cold, allowing liquid water to exist. However, careful attention would be required to avoid runaway greenhouse effects, as seen on Venus, which could lead to catastrophic overheating. Temperature. Regulating Kepler-452b's climate. Kepler-452b, like Earth, is in the habitable zone of its star, but that doesn't mean it automatically has the right temperature for human habitation. The planet's climate could be colder or warmer than necessary, depending on its atmospheric composition, orbital characteristics, and other factors. If the planet is too cold, terraforming efforts might focus on warming the planet. One potential strategy could be to increase the concentration of greenhouse gases like carbon dioxide or methane to trap more heat and warm the atmosphere. Another possibility might be to artificially introduce heat from other sources, such as massive space mirrors that could reflect light onto the planet's surface or space-based solar reflectors that could concentrate solar energy on the planet. Conversely, if Kepler-452b is too warm, we might need to find ways to cool the planet down. One method could involve removing some of the greenhouse gases to prevent the planet from overheating. This could be done by introducing plant life that absorbs carbon dioxide or other methods of carbon sequestration to reduce the greenhouse effect. Gravity. Adapting to Kepler-452b's stronger pull. Kepler-452b's gravity is about 1.6 times that of Earth, which means that any inhabitants would experience stronger gravitational pull. While this may not be an immediate obstacle for basic terraforming, it could affect human health and life forms that evolve or are introduced to the planet. Long-term exposure to stronger gravity could lead to changes in human physiology, such as increased bone density and muscular strength, as well as changes in the way plants and animals evolve. One potential issue with Kepler-452b's gravity is that it could make movement and energy consumption more challenging. Humans, animals, and plants that evolve on the planet would have to adapt to the stronger gravitational forces. For example, trees and other plant life might grow shorter but thicker to support their mass, and animals could evolve to have stronger limbs and muscles to cope with the additional weight. Fortunately, this is not an insurmountable challenge. Over time, life on Kepler-452b could adapt to its environment, and we could design technologies to help human settlers adjust to the increased gravity. Artificial gravity could be used in habitats to simulate conditions similar to those on Earth, giving humans a way to adjust. Introducing life. Building a new ecosystem. Once the atmosphere and climate are stabilized, the next challenge would be introducing life to Kepler-452b. This would involve importing plants, microorganisms, and potentially even animals to create a balanced ecosystem. One of the first steps would likely be to introduce photosynthetic organisms, such as algae or moss, to produce oxygen and help build a foundation for future life. Over time, we could gradually introduce more complex organisms, starting with simple plants and microorganisms, and progressing to larger life forms. Eventually, we could introduce animals to help maintain the ecological balance. However, this process would need to be carefully monitored to ensure that the introduced species are able to survive and thrive in the new environment. Long-term challenges and considerations. While the concept of terraforming Kepler-452b is tantalizing, the timescale for such a project would be immense. The process would take centuries or even millennia to complete. The technological advancements required to terraform a planet are beyond anything humanity has yet achieved. Yet, this does not mean that the possibility of terraforming is out of reach. It is simply a matter of overcoming tremendous scientific and engineering challenges. Terraforming Kepler-452b would also raise profound ethical questions. Would we have the right to alter an alien world? Should we focus on preserving the integrity of other planets and moons? Or is it our responsibility to ensure the survival of humanity by finding new places to live? These questions would likely be debated for years to come, especially as space exploration continues to evolve. The hope of terraforming Kepler-452b. Despite the immense challenges, the idea of terraforming Kepler-452b presents an exciting opportunity for humanity. The discovery of a planet so similar to Earth, located in the habitable zone of a stable, sun-like star, has sparked the imaginations of scientists, engineers, and dreamers alike. Kepler-452b offers a glimpse into the future, where humanity could one day step off our home planet and begin the process of expanding our reach across the stars. As we continue to push the boundaries of space exploration and technology, the dream of terraforming planets like Kepler-452b may one day become a reality. The journey to transforming a distant world into a new home for humanity may be a long one, but it's one that could define the future of human civilization. The search for biosignatures, chemical indicators of life, is one of the most exciting and essential aspects of space exploration. Biosignatures are essentially the fingerprints of life. They are chemicals or patterns that can tell us whether life has existed, or is currently existing, on a distant planet. For planets like Kepler-452b, which are located 1,400 light-years away, identifying these biosignatures is a crucial step in determining whether the planet is habitable or even inhabited. For decades, scientists have been developing new techniques to look for these signs, and with the advent of advanced telescopes like the James Webb Space Telescope, JWST, we are closer than ever to unlocking the secrets of distant exoplanets. Kepler-452b, with its Earth-like characteristics, is a prime target in the search for biosignatures. Let's delve into what biosignatures are, how we can detect them, and what we might find if we were to analyze Kepler-452b's atmosphere and surface for signs of life. What are biosignatures? A biosignature is any substance, element, or phenomenon that can provide scientific evidence of past or present life. These can range from gases in the atmosphere to chemical compounds on the surface of a planet. Essentially, biosignatures are the physical or chemical evidence that suggests life has influenced the environment in some way. On Earth, life is responsible for a variety of chemical imbalances in the atmosphere and oceans. For example, our atmosphere is rich in oxygen and ozone, two gases that are largely produced by photosynthetic organisms like plants and algae. Additionally, methane is produced by microbial activity in places like wetlands and the digestive systems of animals. These gases are often detected as biosignatures because their presence in large quantities would be unusual without life's involvement. In the context of Kepler-452b, searching for biosignatures would involve looking for gases or compounds in its atmosphere that could indicate biological activity, either in the form of microbial life or more complex organisms. While the presence of these biosignatures wouldn't be proof of life, it would strongly suggest that Kepler-452b could potentially host life or that it has in the past. Key biosignatures to look for on Kepler-452b. When astronomers search for biosignatures, there are a few key gases and compounds that they typically focus on because they are strongly linked to life on Earth. Let's explore some of the most important ones that we might look for in the atmosphere of Kepler-452b. Oxygen, O2 oxygen, is perhaps the most well-known biosignature. On Earth, oxygen is produced by photosynthetic organisms, plants, algae, and cyanobacteria, through a process that uses light to split water molecules and release oxygen into the atmosphere. In a planet's atmosphere, large quantities of oxygen can be a strong indicator of life, particularly if it is present in non-equilibrium concentrations. In other words, if the amount of oxygen in the atmosphere exceeds what would naturally be expected from chemical processes alone. If oxygen were to be detected in the atmosphere of Kepler-452b, it would be one of the clearest signs of biological processes. However, the presence of oxygen alone isn't enough to prove life. It must be accompanied by other clues, such as the right balance of gases. Methane, CH4 on Earth. Methane is a gas that is primarily produced by microbial life in environments like wetlands, as well as by the digestive processes of animals. It is also produced by volcanic activity and geological processes. While methane can be formed through non-biological processes, the amounts we find on Earth are typically tied to biological activity. In the case of Kepler-452b, if methane is detected in its atmosphere, it could be an indication of microbial life. The combination of methane and oxygen is particularly interesting because these gases react with each other. If both gases are found together in a planet's atmosphere, it could suggest that a biological cycle, like the one we have on Earth, exists there. This is one of the strongest potential biosignatures. Carbon dioxide, CO2 carbon dioxide is an important greenhouse gas that helps regulate a planet's temperature. On Earth, it plays a major role in supporting life by stabilizing the climate. It is also a byproduct of respiration in animals and the decay of organic matter. The presence of carbon dioxide on a planet like Kepler-452b could be a sign of life's influence on the environment, particularly if the planet's atmosphere has an unusual concentration of CO2 that exceeds what would be expected from just volcanic activity or geological processes. On Earth, carbon dioxide is essential for plant life, as plants use it in the process of photosynthesis to create organic matter. If carbon dioxide is detected in high concentrations, it could point to life's role in producing and cycling this gas. Nitrous oxide, N2O nitrous oxide, is another important biosignature gas. On Earth, nitrous oxide is produced by microbial activity in soils, wetlands, and oceans. It is also created in the digestive systems of animals. Nitrous oxide is used in a variety of biological processes, and its presence in an exoplanet's atmosphere could indicate microbial activity. If nitrous oxide is detected on Kepler-452b, it would suggest that life is likely involved in creating this compound. Ozone, O3 ozone, is another key biosignature that is typically associated with the presence of oxygen in an atmosphere. On Earth, ozone is created when ultraviolet light from the sun interacts with oxygen, producing a protective layer that shields the surface from harmful radiation. While ozone can be created through non-biological processes, it is often associated with biological oxygen production. Therefore, the detection of ozone in the atmosphere of Kepler-452b could indicate that oxygen is present, and that biological processes may be at work. How we can detect biosignatures on Kepler-452b. Detecting biosignatures on a distant exoplanet like Kepler-452b is no simple task. The planet is located about 1,400 light-years away, making it difficult to gather detailed information. Fortunately, advances in astronomical instrumentation and space telescopes have made it possible to study the atmospheres of distant planets with greater precision. The most promising technology for detecting biosignatures is spectroscopy, the study of the light that passes through a planet's atmosphere as it transits its star. When a planet passes in front of its star, a small amount of its atmosphere can block or absorb certain wavelengths of light. By analyzing the remaining light, scientists can infer the composition of the atmosphere. The James Webb Space Telescope, JWST, which is set to launch soon, will be one of the most powerful instruments for studying exoplanets and searching for biosignatures. JWST's infrared capabilities will allow it to observe exoplanets in unprecedented detail, even those that are far away like Kepler-452b. JWST will be able to detect a wide range of chemical signatures in a planet's atmosphere, including the gases we associate with life on Earth. Another promising method is direct imaging, which involves capturing detailed images of exoplanets and their atmospheres. While this technique is still in its infancy, advances in technology will likely make it possible to directly observe the surfaces and atmospheres of planets like Kepler-452b in the future. What will we find on Kepler-452b? While we can't yet say for certain what Kepler-452b's atmosphere contains, the planet's position in the habitable zone and its Earth-like characteristics make it an exciting candidate for the search for biosignatures. If the planet has liquid water and a stable atmosphere, it could support life, or at least have done so in the past. The detection of biosignatures on Kepler-452b would be one of the most profound discoveries in the history of science, providing strong evidence that life is not limited to Earth. Scientists are already planning missions to observe and study exoplanets like Kepler-452b, and it's only a matter of time before we have a clearer picture of this distant world. Whether we find signs of life or not, the search for biosignatures will continue to drive our exploration of the cosmos, as we search for answers to one of humanity's oldest and most profound questions. Are we alone in the universe? Studying a distant planet like Kepler-452b is an exciting scientific pursuit, but it is also fraught with challenges. The very distance that makes Kepler-452b so intriguing also makes it incredibly difficult to study in detail. The planet is located a staggering 1,400 light-years away from Earth, which is far beyond the reach of our current space exploration capabilities. To put that into perspective, 1 light-year is about 5.88 trillion miles, 9.46 trillion kilometers. At such a distance, gathering detailed data about the planet's atmosphere, surface conditions, and potential to host life becomes a monumental task. Despite these challenges, scientists are making incredible strides using advanced space telescopes, indirect measurements, and theoretical models to uncover the secrets of this distant world. In this section, we'll explore the key challenges involved in studying Kepler-452b, the methods scientists use to overcome these obstacles, and the promising future technologies that could one day provide us with clearer, more detailed images of this potentially habitable exoplanet. The distance, a barrier to detailed observation. Kepler-452b's location, 1,400 light-years away, presents a primary challenge for astronomers. Light, which travels at a speed of about 186,000 miles per second, 300,000 kilometers per second, takes 1,400 years to reach us from this planet. This distance means that Kepler-452b is far beyond the reach of any current spacecraft, so we must rely on remote sensing techniques to gather data. Even though this planet is relatively close in cosmic terms compared to other exoplanets, the distance makes it nearly impossible to get detailed images of Kepler-452b or study its surface directly. Instead, astronomers have to work with indirect data, mostly from the Kepler Space Telescope and other space-based observatories, gathered through the light emitted or reflected by the planet or its star. This limited data leaves much to the imagination and often requires a lot of interpretation. Moreover, because we cannot send probes to Kepler-452b, we have no way of directly sampling its atmosphere or surface. This limitation means that most of what we know about the planet's potential to host life is based on theoretical models and observations of similar exoplanets. We can't be sure about the presence of liquid water, a thick atmosphere, or the exact surface conditions of Kepler-452b until we have more advanced tools and methods to study it. Indirect methods of study, transits, and light curves. Despite the vast distance, Kepler-452b was discovered using the transit method, one of the most effective ways of detecting exoplanets. The method works by measuring the small dip in light that occurs when a planet passes in front of its star from our perspective on Earth. This is called a transit, and the Kepler Space Telescope spent years observing the light from hundreds of thousands of stars to detect these transits. When a planet passes in front of its star, it causes a tiny but measurable dimming in the star's light. By studying these dips in brightness, astronomers can learn about the planet's size, orbit, and distance from its star. In Kepler-452b's case, the data suggested that it is about 1.6 times the size of Earth, making it a super-Earth, and its orbital period of 385 days indicates that it is in a similar orbit to Earth's around the Sun. While the transit method provides valuable information, it doesn't give us direct details about the planet's atmosphere, surface conditions, or whether it can host life. To get more detailed data, scientists must rely on further techniques like spectroscopy, which requires analyzing the light that passes through the planet's atmosphere as it transits its star. Spectroscopy, analyzing the atmosphere. One of the most promising ways to learn more about Kepler-452b is through spectroscopy, a technique that analyzes the light from a planet as it passes in front of its star. As light passes through a planet's atmosphere, different gases in the atmosphere absorb light at specific wavelengths. By studying these wavelengths, scientists can infer the composition of the atmosphere. This method has been used on other exoplanets, and it holds great potential for studying Kepler-452b. For example, we could search for biosignatures, gases like oxygen, methane, and carbon dioxide, which might indicate the presence of biological activity. However, the challenge of studying a planet so far away is that even with spectroscopy, the data we receive is often not detailed enough to fully characterize the planet's atmosphere. Astronomers use space-based telescopes like Hubble, Spitzer, and the upcoming James Webb Space Telescope, JWST, to perform these types of analyses. JWST, with its advanced infrared capabilities, will be able to study exoplanet atmospheres in much greater detail than previous telescopes. JWST will allow scientists to directly detect biosignatures and gather more information about Kepler-452b's atmosphere. However, the planet's great distance means that it will still take a lot of time and effort to gather enough data to draw definitive conclusions. The James Webb Space Telescope, JWST, a game changer. The James Webb Space Telescope, JWST, set to launch soon, promises to be a game changer in the study of exoplanets like Kepler-452b. JWST's infrared capabilities will allow it to peer through the planet's atmosphere, analyzing the light emitted or reflected by the planet. This is particularly important for exoplanets like Kepler-452b, which may have faint or distant light sources that require highly sensitive instruments to detect. JWST's ability to study atmospheric composition and look for key biosignatures will be invaluable in the hunt for life on planets like Kepler-452b. Using its instruments, JWST will be able to observe the spectral lines of gases like oxygen, methane, and water vapor, and even determine the presence of clouds, temperature, and weather patterns. This will provide much-needed insights into the potential habitability of Kepler-452b. But even with the power of JWST, Kepler-452b's distance will present challenges. The planet's small size, coupled with its distance from Earth, will make it difficult to obtain the kind of high-resolution images we can get from closer planets or objects. Even with advanced technology, it will take time to piece together a clear picture of Kepler-452b's atmosphere and surface. The limitations of current technology. While modern telescopes and instruments have revolutionized our ability to study exoplanets, there are still significant limitations to what we can achieve with current technology. Kepler-452b, like other exoplanets, presents unique challenges due to its distance and size. The farther away a planet is, the more difficult it becomes to gather detailed data, especially when it comes to its atmosphere and surface conditions. We have yet to develop technologies that would allow us to directly sample the atmosphere or land on exoplanets. Without these capabilities, we must rely on indirect methods, such as studying the star's light, analyzing the planet's transit data, and observing spectral signatures to infer what the planet might be like. This means that we cannot say for certain whether Kepler-452b harbors life or if it has conditions conducive to life. While these limitations are frustrating, they also present an opportunity for future advancements in space exploration. As technology progresses, new instruments will likely be developed that will allow us to study distant planets with greater precision. For example, future space missions may involve advanced telescopes with even greater sensitivity or even space probes capable of visiting exoplanets. These advances could pave the way for a much clearer understanding of Kepler-452b's potential to support life. The role of future missions and technologies. As we look to the future space missions will play a key role in answering the most important questions about Kepler-452b. For example, a mission that directly studies the planet's atmosphere or even sends probes to explore it could provide definitive answers about the planet's potential for life. These future missions will require advanced propulsion systems, improved astronomical instruments, and new spacecraft designs that can travel farther and faster than anything we have today. In addition to JWST, other upcoming missions, such as the Nancy Grace Roman Space Telescope and future probes, will contribute to the search for habitable worlds and help us study the biosignatures of distant planets. Together, these missions will help piece together the puzzle of whether Kepler-452b, one of the most promising exoplanets discovered, could indeed be the next great step in the search for extraterrestrial life. The excitement of the search. Looking ahead. Despite the challenges, the search for life on planets like Kepler-452b is an exciting and important step in the broader search for life beyond Earth. The difficulties of studying exoplanets from such great distances only make the eventual discoveries more rewarding. As technology continues to evolve, so too will our ability to study planets like Kepler-452b in greater detail. In the not-so-distant future, we may have a much clearer picture of this distant world, and perhaps even discover the first signs of extraterrestrial life. The journey to uncover the secrets of Kepler-452b is just beginning, and the potential to answer one of humanity's oldest questions, are we alone in the universe, is closer than ever before. Kepler-452b stands as one of the most exciting and promising planets in the search for life beyond Earth. With its striking similarities to our home planet, its location in the habitable zone of a sun-like star, and the potential for liquid water, Kepler-452b offers a tantalizing glimpse into what might be possible in the search for extraterrestrial life. It represents not just the possibility of finding life on another planet, but also the deep yearning within humanity to understand its place in the vast, mysterious cosmos. While the future of space exploration is brimming with excitement, the journey to uncover the secrets of distant worlds like Kepler-452b has only just begun. As technological advancements continue to accelerate, we will be able to gather more information about this distant planet and others like it. Tools like the James Webb Space Telescope, JWST, spectroscopy, and future missions will allow us to peer deeper into the atmospheres of exoplanets, study their chemical compositions, and determine whether they might harbor life, either in the form of simple microbes or more complex organisms. However, even if Kepler-452b does not turn out to be the home of life, its discovery serves as a key piece in the ever-expanding puzzle of understanding the universe. Whether or not we find life on Kepler-452b or any other exoplanet, the search for life beyond Earth is an ongoing journey that will undoubtedly push the boundaries of human knowledge and exploration for years, if not centuries, to come. A monumental moment in human history. The discovery of life on Kepler-452b, whether microbial or more complex, would be a monumental moment in human history. For centuries, humanity has gazed up at the night sky, wondering if we are alone in the universe. The search for life beyond Earth has been a central question in our scientific, philosophical, and cultural development. If life were to be discovered on Kepler-452b, it would not only answer that question, it would fundamentally change our understanding of life itself. It would suggest that the conditions that foster life might not be unique to Earth, but could exist in many places across the universe. Imagine the profound implications for science, philosophy, and religion if we were to find that life exists beyond Earth. What would it mean for our conception of consciousness, intelligence, and existence? Would our understanding of biology and evolution change? Would humanity need to reconsider its place in the universe and its responsibilities as stewards of life? These are just a few of the deep questions that would arise from the discovery of extraterrestrial life. Moreover, the discovery of life on Kepler-452b could ignite a wave of space exploration, scientific inquiry, and collaboration that would unite people across the world in a common cause: understanding the nature of life and our place in the cosmos. It would be a defining moment not just in science, but in the story of humanity. The search continues, a never-ending journey. Despite the monumental significance that the discovery of life on Kepler-452b could have, the search for life beyond Earth is not just about finding life. It is about the journey itself. As we continue to push the boundaries of space exploration, we are constantly learning more about the universe and our place within it. Kepler-452b, with its Earth-like properties, is simply one of many steps in this journey. There are countless other planets out there, some perhaps even more promising than Kepler-452b, that could hold the key to answering one of the oldest and most profound questions humanity has ever asked. Are we alone in the universe? The search for life beyond Earth also reminds us of the vastness of the universe. Even though we may never reach all the stars, the knowledge we gain about exoplanets, galaxies, and the building blocks of life helps us better understand the incredible complexity and beauty of the cosmos. This search encourages us to explore new horizons, to look beyond the limits of our own planet, and to dream about what might exist in the unexplored regions of space. In addition to expanding our scientific knowledge, the search for life also touches upon something deeply human: our desire for connection. Whether or not we find life, the quest itself can inspire unity, curiosity, and wonder in people around the world. As we look for life on planets like Kepler-452b, we are not just seeking answers to scientific questions. We are engaging in a collective effort to understand our origins, our future, and the mysteries that lie beyond. The future of space exploration, beyond Kepler-452b. As we look to the future of space exploration, the discoveries we make about Kepler-452b and other exoplanets will likely open up new frontiers of knowledge. The advent of next-generation telescopes, space missions, and advanced spacecraft will allow us to explore planets and moons in even greater detail. Future missions will examine planets much farther from Earth and study their atmospheres, surfaces, and potential for life with even more precision. In the coming decades, we might send robotic probes or even human missions to some of the most promising exoplanets. While Kepler-452b might not be the first planet to host human explorers, it may very well become a symbol for our determination to venture into the unknown, to understand the nature of life, and to answer the ultimate question: are we truly alone in the universe? In the meantime, we continue our search for biosignatures, those subtle clues that life might be out there. Kepler-452b might be the first world where we catch a glimpse of those signs, but it won't be the last. The universe is vast, and the potential for life is limitless. Each discovery, whether it's a glimpse of a distant exoplanet's atmosphere or the detection of a faint biosignature, brings us one step closer to understanding the cosmic web of life that could stretch across countless worlds, galaxies, and systems. Whether we find life or not, the search will endure. Finally, even if we never find life on Kepler-452b or any other exoplanet, the search will not end. The mere fact that we are searching, and the insights we gain along the way, will continue to inspire future generations. The drive to understand the universe is one of humanity's most profound traits. It is a drive that pushes us to innovate, to explore, and to reach out to the stars. Whether life is found on Kepler-452b or another world, the search for extraterrestrial life will continue to shape the future of space exploration, science, and human curiosity. In the end, the journey toward answering the question, "Are we alone?" may be just as important, if not more important, than the answer itself. The search brings us together as a species, uniting us in our common desire to explore, to discover, and to understand the vast and mysterious universe around us.